Hello. So hopefully I'm audible and visible. So how are you guys? How's everything going? Okay. Sorry. Okay. So let's start the class now. So what are we going to study in this class today? Um, so yeah, we are going to continue where we left previously, right? We are going to see what is fluid mechanics. This is, by the way, lecture 3. So let me just correct it. Lecture 3. Okay, this 3 looks weird. Okay, my name is Faiz Khan. We saw density. We already completed this density of a liquid, right? We already completed relative density of liquids. We kind of completed mixture of liquids. Now we have to see effect of temperature on density and effect of pressure on density, right? What if I increase the temperature or pressure? So what will happen to the density of that liquid? That what we are going to see. Okay. So before starting, let me recall certain things. For example, binomial expansion. We have studied binomial expansion, right, in the chapter gravitation. No, sir, we have studied that in the chapter binomial expansion in class, in mathematics class. Yeah, we also studied that in physics as well, right? What did we study? We studied this. Let me recall. 1 plus x to the power n. This was a special case of binomial expansion, right? What was it? 1 plus x plus 1 plus nx plus n minus 1, x square by 2 factorial plus n minus 1, n minus 2, x cube by 3 factorial, and so on. So what will be the next term? Can you figure out? Yes, n minus 1, n minus 2, n minus 3, x to the power 4 divided by 4 factorial. For example, let me take an example. 1 plus, let's say there's a question like this: 1 upon 1 plus d under root. We have to expand this. What we can write it as? We can write it as 1 plus d to the power minus 1 by 2, right? So on comparing, the value of x is d. And on comparing, the value of n is minus 1 by 2. Just substitute that in the formula. What will you get? 1 minus 1 by 2 into d plus 1 by 2 minus 1 by 2 minus 1 by 2 minus 1 minus 3 by 2 into d square by 2 factorial, and so on. On solving it a bit, you'll get your answer, right? So hopefully this binomial expansion is clear to you all. So I'll give you some time to note it down. Note it down fast, then we'll move ahead. And one more thing I would like to say is, hopefully you have gone through the JEE or question paper, which was conducted recently. Try to solve the 11th portion. That would be helpful for you guys, right? Okay. Hopefully you have written this. Now, volume expansion. What is volume expansion? If volume expands, just give me a Okay, sorry for the interruption. Let's see once again what we were studying. Volume expansion. I was telling you guys about volume expansion. So what is volume expansion? You might have studied that in the, rigid body dynamics. So let me tell you a little about volume expansion. So whenever the volume expands, we can say the change in volume is equals to original volume times gamma times change in temperature. So I can write it temperature as T as well, but in some books they prefer, theta. So what is this? Let me just tell you again. What is dV? The change in volume. How if I'm increasing the temperature of certain body, let's say if I take this bottle, okay, if I'm increasing the temperature of this bottle, what will happen? A little volume of this bottle will increase, right, from inside. So that change in volume will be proportional to two things. Okay, this change in volume will be proportional to two things. First is the original volume. If it has originally greater volume, then the change in volume will be greater, right? If this bottle was smaller one, then the change in volume will also be small. Now, this is also proportional to the change in temperature. If I'm increasing the temperature more, then the change in volume will be greater, right? So if I combine these two, what will I get? V delta T proportional to, when I remove this proportionality, I have to include a constant which is gamma, which is called coefficient of change in volume, you can say. Okay, okay. Thermal coefficient of volume expansion. I'll write it down here. Gamma is thermal just a sec guys. Thermal coefficient of volume expansion. Okay, some technical issues are going on. Okay, so thermal expansion of volume. Let me just do one quick thing. Just give me a second. Um, okay, hopefully I'm audible and visible. There's some technical glitch going on right now, which I'm trying to figure out. Um, yeah. Um, okay, hopefully I'm audible and visible. Yep, I'm audible and visible. Okay. So let's begin. Let's restart whatever few for the interruption, everyone. Yeah. Okay. So just write it down. Just write this expression down. We are going to use this expression in today's class. Okay. Just write this down. Write this expression down, guys. Okay. So let's go ahead. What we were studying next. What is the use of volume expansion? So a very practical explanation. Just listen to me carefully. Okay, a very practical explanation about this is this. Have you seen the railway tracks? Right, in the railway, you might have seen this cuttings. Okay, and in some bridges as well. So why do they do that? So why do they do that? It's a very interesting question. Have you guys seen? See, I'm going to tell you the practical. If my voice was not clear, I'm going to tell you the practical explanation of volume expansion. Okay, practically where you can see volume expansion. So, have you guys seen these types of breaks in railway tracks? Why is that? Because in the time of what do you say summer or when it is very hot in certain region, right? What happens is what happens is the metal, due to change in temperature, due to increase in temperature, the metal expands. Okay, when the metal expands, now if there is no crack like this, okay, if there is no crack like this, what will happen is this metal will break itself apart. It will break itself apart and there is a high yield. So that's why what we do is we create certain breaks after certain lengths of railway tracks, right? Now let's move on to bulk modulus. You might have heard about bulk modulus, studied about bulk modulus. So does anyone knows anything about bulk modulus? Okay, let me tell you, it also gives us the change in volume, but this gives us the change in volume due to the external pressure. Okay, it gives us the change in volume due to external pressure. So what is external pressure, sir? If, for example, this cube, right, this light blue one, it was the original cube. What I'm doing is towards uh, from every direction, I'm applying force. Okay, and or I can say I'm applying pressure from every direction. So what will happen is it will shrink a bit, right? So what is the equation related to that? So it's very simple. The change in volume is proportional to change in pressure. How much pressure you are changing? Okay, the change in volume is also proportional to the original volume. Now, if you combine this, the change in volume will be equal to dp v, and the constant here is b, and b is called bulk modulus and it comes in division. Okay, so what I can say is dp, change in pressure, is equals to b dv by v. See, these two equations are equally valid, right? So hopefully this is clear. See, why am I telling you like this? Why am I deriving these equations like this? Because so that you can remember them. Okay, the change in volume is directly proportional to change in pressure. The change in volume is directly proportional to what do you say, change in original volume. Now, if you combine it, you have to um, place a constant of proportionality. So here B is the constant of proportionality. So hopefully this is clear, right? Okay. Then we saw this density, relative density, density of two mixtures, etc. Now, what we are going to do is we are going to see what is the effect of what is the effect of temperature on density, right? Okay. So I'm writing it down. Just write it down with me, okay? Just note it down with me, then I'll explain you what I'm saying. As the temperature, okay, okay, let me explain first. Okay, that would be nice. Okay, for example, if I'm taking a bulk, if I'm taking, let's say, certain cube, okay, it is filled with certain amount of liquid. Okay, it is filled with certain amount of liquid. What I'm doing is, first let me draw the liquid first. Yeah, what I'm going to do is, I'm going to increase the temperature of this liquid. Okay, I'm going to increase the temperature of this liquid. Oh, what a drawing. Okay, I'm going to increase the temperature of this liquid by adding some heat inside it. Okay, by adding some heat, I'm going to increase the temperature. After that, what will happen is, tell me one thing, what will remain same? If the liquid is in the box and the box is, let's say, closed. Okay, so what will remain same? Can I say mass remains constant? Yes or no? Mass remains constant throughout. Since it is a closed box, the mass will remain constant, right? Okay. What will change? The volume will change, right? Volume will change. This gas, it will convert into vapor form, or if not even vapor form, if we are slightly changing, then the molecules will grow apart, right? They will, move apart. If they are moving apart, then they will occupy more volume. Then the volume will change, and specifically, if the temperature is increasing, volume will also increase, right? Can we say that? Okay. And we know density rho is equals to mass by volume. Since mass here constant, since mass is constant, can I say density is inversely proportional to volume, right? Okay, so change to density, let's say rho dash upon original density will be equal to original volume upon changed volume. Yes or no? What can I say? What can I say? The changed volume will be equal to original volume plus slightly increase in volume dV, right? The change in volume will be equal to original volume, the change, right? Sorry, this is final volume. I'll write it down here. This is final volume. Final volume. The final volume will be equal to original volume plus change in volume, right? Okay. We already saw if the temperature is increasing, then what is the what do you say, change in volume? So sir, we don't remember. So I told you how to derive it. The change in volume is proportional to which quantities? Original volume. The change in volume is proportional to change in temperature. Combining these two, that will be equal to gamma V delta T, right? Just substitute it here. V plus gamma V delta T. Now, if I take V common, it will cancel out. It will be 1 by 1 plus gamma delta T. Hopefully this is clear, right? Hopefully this is clear. So this is very important. Change in density is equals to original density upon 1 plus gamma delta T. So note it down. This is very important. A lot of numericals can be solved using this formula itself. A lot of numericals can be solved using this formula itself. So note it down, guys. Note it down. This is very important. You don't have to remember this. If if you practice it multiple times, you don't have to even remember the formula. Okay. So hopefully this is clear, right? Now let's move on. Let's move on. Effect of pressure on density. What will happen if I apply pressure on certain body? So as we saw in the previous one, I'm sorry guys, a lot of cold. Okay, so yeah, for example, if there is a box, let's say, and it contains a certain amount of liquid in it, right? What if what am I doing is, I'm just taking a piston kind of thing and applying pressure. Okay, some pressure. So what will happen to the density after applying certain amount of pressure? So, so tell me one thing, if I'm applying pressure on it, okay, what will remain constant yet again? Mass will remain constant, right? Mass is not going anywhere. Is mass going anywhere? It's not going anywhere. So mass will remain constant. If I'm applying pressure on it, then the molecules will get closer, right? The molecules will get closer and the volume will decrease. The molecules will get closer and the volume will decrease, right? If I'm applying pressure, pressure increases, volume decreases. So density is equals to yet again mass by volume. Since mass is constant, density is inversely proportional to V. So what can I say? Density, change in density, final density upon original density is equals to what will happen here? V upon V dash, right? What is V dash? We just calculated, we can say V dash is original volume plus change in volume. And we calculated the change in volume, right? In case of pressure applied. So change in volume will be directly proportional to change in pressure, and change in volume will be directly proportional to original volume. If you combine these two, so this will be V dP and divided by B. Remember, right? So just substitute it here, V upon V plus V dP by B. Now, will we consider here as plus or minus? Tell me, the volume is changing and volume is decreasing, right? So original volume minus change in volume. So we just have to take minus here. Just write it down, minus. So what will happen next? Hopefully I'm audible to you all. Am I audible to you all? Hopefully. Yeah. So V gets common and gets cancelled out. Rho will be equal to rho upon 1 minus V dP by B. So I'll write it down in a cleaner manner so that you don't get confused. Upon 1 minus dP by B. So hopefully this is clear. If there is a change in pressure, then what we have to do is we have to use this equation. Okay. So note it down, guys. My video is getting stuck after and after, and I'm jiggling like a bobblehead for some reason. Okay, just note down this formula. Just note down this derivation. It is an important one. I'm giving you 2 minutes to note it down. Then we'll solve a question. Note it down, guys. Then we'll, move ahead. Okay, hopefully you have noted it down. Now, let me move ahead. Now, next, what I'm going to talk about is Pascal's law. Okay. So what is Pascal's law? So Pascal basically said, Pascal law says, I'll write it down according to Pascal's law. According to Pascal's law, for a where is the eraser? Yes, for an incompressible fluid, the pressure exerted anywhere is transmitted equally in all directions. Okay. Now, for example, let me take an example of well-known YouTube. Not that YouTube. Okay, the YouTube, the U-shaped tube, right? Okay, so I'm taking a liquid in this, right? Let me just fill it up. Let me fill the liquid inside this U-shaped tube. Okay, if I apply pressure in this direction, let's say P1, then the pressure in this direction will also be equal to P1. As simple as that. If I apply pressure in this direction, the pressure in means whole fluid will be equal, right? Okay. What if the area here is A1? and the force applied here is F1. So can I say F1 A1 will be equal to area here is, let's say, A2, and force applied here is F2, F2 A2, right? So this is basically Pascal's law. As simple as that. The pressure applied in, sorry guys, the pressure applied in an incompressible fluid. The main thing to note down is in an incompressible fluid means we are taking ideal fluid or a fluid which can't be compressed as an example. All right. Okay. So the main thing of this fluid is, sorry, that's not the main thing. Sorry for all the interruptions. The main application of Pascal's law. Application of Pascal's law. So it is used in, the main application is, it is used in hydraulic lifts. Let me give you a feel what an hydraulic lift is. For example, you might have seen, in stages, what happens is the guy or the car, let's say there's a car expo, okay, where they show the car. So what they do is the car comes from underground and it appears on the stage, right? Or in car showrooms, they bring the car up using some sort of, lift. How does that lift work? Let me show you. Okay. So, for example, this is the platform where car is being kept. So let me draw a car real quick. Okay, this is a car for. Okay, okay. Now, what they do is they connect this on the other side. They connect it with a, like this. This area is, let's say, A1. Okay, and this area is, let's say, A2, right? We know the relation between pressure and area, right? Pressure is equals to force by area. So can you tell me, if the area is more, the pressure will be less, right? If the area is more, the pressure applied will be less, right? Okay. So see, here the area is very much, the area is very big, right? So to lift this car up, now since, can I say, if I apply pressure P here, then the same pressure will be applied. If I apply pressure P here, the same pressure will be applied here. So pressure is same, right, in both the cases. So if I say pressure is constant, if I say pressure is constant, P is equals to F by A, can I say force is directly proportional to area? If pressure is constant, then force is directly proportional to area, right? Okay. If I increase the area, the force exerted will be more. Yes or no? Now, since here the area is very less, I have to apply certain amount of force. Since the area here becomes very big, the same means more force will be applied here. If more force will be applied, means with less force, means applying less force in this direction will lift the car up. Means if I give you an example now, what happens here? If I, means a guy of, let's say I'm 80 kgs, okay, 80 kg guy stands on that platform, I can lift about 2000 kg around weight on this side. Since the pressure is equal, there is a change in area. Right? Due to the change in area, the force applied here, less force you apply, that force will become more and more here because the area is more. Hopefully you get that. Hopefully it is clear, right? Here, less force. Since the area is more, the force here will be more, right? So what is the equation? Since the pressure is same, I can say F1 A1 will be equal to F2 A2. Right. So let me solve a question. Okay, thank you, Ageto. Okay, let me solve a question real quick. Yeah. Let me give you guys a question. I'll give you guys the question here. Find the force exerted Find the force exerted on the hydraulic lift to lift a car of 3000, sorry, extra zero again, sorry, of 3000 kg mass if it is kept on a platform of area 10 ज़्यादा हो जाएगा. I'll give you something realistic, that is 5 meters square, and the force is applied on, an area of 100 centimeters square. Solve this. I'm giving you 2 minutes to solve this question. Go ahead and solve this question. Solve this question, guys. 2 minutes. Okay. Let me solve this question. All right. Let me solve it. Pretty simple. Yeah. So I have to erase this because I don't have some space. Yep, gone. Okay. So let me solve this. What was I solving? Yeah, the question is find the force exerted on the hydraulic lift to lift a car of 3000 kg. Means the weight of the car is, mass of the car is 3000 kg, right? Okay. So what they say, if it is kept on a platform of area, means area of car will be equal to 5 meters square. Not area of car, but the area on the platform with on which it is kept. Area of where we have to apply forces 100 centimeter square. Let me convert it into meter square real quick. Or what I can do is I can convert this into centimeter square. You can do either. 1 meter is equals to 100 centimeter, right? So 1 meter square, squaring both sides, will be equal to 1234 centimeters square. So just multiply with it, 1234 centimeters square. Now, what should be the force applied here on F? So we know F1 A1 will be equal to F2 A2, and in this context it is F of F into A of F, means force applied into area of force applied is equals to force of car into area of car, means the area in which the platform is kept. So we have to calculate F of F. Let it be F. Area is 100 centimeter square. Force of car, so mass is this, so gravitational force will be equal to mg. So 3000 into 10. Let us take the value of g as 10. Area of this is 34. So what will be the answer? F is equals to 1234 into 5 into 1234 divided by 100. Two zeros and two zeros will cancel out. What will be the answer? The answer will come out to be, if I choose a 15, 1.5 into 1, 2, 3, 4, 5, 6. 10 to the power 7, not 6, 7. 1.5 we took, right? 7 Newton. So hopefully this is clear. I think I messed up one thing. Yeah, sorry. I messed up with the formula. Here it should be 2. Yeah. Here it should be A2. Here it should be A1. Why is that? Force upon area is equals to pressure, right? So can I say F1 upon A1 is equals to F2 upon A2, right? So F1 A2 will be equal to F2 A1. That's what I'm thinking. How is it so large value, right? Okay, let me just correct my mistake really fast. So force area of car will be equal to force of car into area of force. So what will be the answer? Force area of car is 5, 1, 2, 3, 4. Force on car is 3, 1, 2, 3, 4. Area is 100. This is 100. I've just substituted the value. 4 zeros and 4 zeros will cancel out. You are left with 3 into 100 divided by 5. This will cancel out to be 20. That will be equal to 16 Newton. So can you believe it? A car of weight something around 30,000 Newton can be simply brought up using a 60 Newton force. Or if I convert this into mass, that will be equal to 6 kg mass. Approx, you keep a 6 kg mass and it will bring up a 3,000 kg car, which is very interesting to know, right? Hopefully this formula is clear. F1 A2 is equals to, or you can just remember this, F1 upon A1 is equals to F2 upon A2, right? We just use the formula for pressure here, right? Okay. So I was supposed to end the class here, but okay, we have time. What we can do is we can solve a question related to change in temperature as well. Question. Find the change in volume, not volume, find the change in density of water. Water ka density, what is the density of water? 1000 kg per meter cube, right? When temperature is increased from 4 degrees Celsius to 10 degrees Celsius. And the value of gamma for water, I'm just assuming 1380. Okay, just solve it. Not 1380. Let me give you an easier option to work with. 1, 6. Let's say 100. All right, 100. The value of gamma is 100. Giving you 5 minutes to solve this question. Go ahead and solve this. Not 5 minutes, 2 minutes is sufficient, I guess. Solve this, guys. Okay, solve it. Hopefully you have at least tried it, right? I'm just directly using this formula. Change in density will be equal to density, that is 1000 divided by 1 plus 100 into change in temperature, that will be equal to 6. Normally, whenever you're solving question, always change this change this quantity 4 degree Celsius into Kelvin and then solve it. But in this case, Kelvin, the change in temperature is equal for Celsius as well as Kelvin, right? So what will be the answer? Sorry, 1000. You keep things. Uh, 1000 divided by 600 into 1601. So to bring an approximate answer, I'm assuming it to be 600, 0, 0. That will be 5 by 3. 5 by 3, that will be 1.67, close to. Okay, I have messed something up. Maybe the value of gamma, right? The value of gamma we have taken as wrong. Okay, but the answer is this. Hopefully this is clear, these type of questions, right? Let's solve a few more questions, then we'll wrap up this. Okay. Okay. I have one question which I would just take it from this. Okay. Wait, was I was giving you guys a question, right? Right. Well, this not work for some reason. This thing is so hopefully you can see this question with diagram, right? The screen share is loading. This give it a sec. Load. Yeah, this. The 16.5 to solve this question, then we'll discuss this question. To solve it, in 5 minutes. Pretty easy question. You Akshay said previously totally is about the change in pressure with the height, right? So you can use that concept here as well. Use it. Okay, let's solve this. Come on. So I'll solve this question now. So pretty simple. For the system shown in figure, the cylinder on the left at L, what we're talking about, okay, has the 600 kg and a cross-sectional area of this. Means mass on this side is given as 600 kg and area on left side is given as 800 centimeters square, right? The piston at S has cross-sectional area here. area is given as 25 centimeters square. One good thing is both the units are same, right? And negligible weight. If the apparatus is filled with oil and the value of rho for oil is given, what is the force F required to hold the system in equilibrium? Okay, so the value of F you have to calculate. So let me just give you a hint. The pressure on both the sides will be equal, right? Pressure on left should be equal to pressure on right if it has to be in equilibrium. On left, the pressure is force by area, right? Okay. Anything else? Any more pressure does it has? Can anyone tell me? Any more pressure does it has? Let me just show you. Here. See, pressure on the left should be equal to pressure on the right, right? So pressure on the left is equals to F by A2 plus rho GH, and on the right it is equal to mg by A1. Let me just clear it. Yeah, let me write it down. See, here pressure here on the top portion will be equal to force by area, plus on going downwards 8 meter it will be equal to rho GH. Now this pressure, this total pressure, this is the pressure at this point. Pressure at this point should be equal to pressure at this point, right? Because horizontal pressures are equal. That will be equal to force by area. And what is force in this case? What is force in this case? Okay, where is pen? Okay. The force is mt by area A2. So we have to calculate force. What is area here on the left side? The area is, what is the area here on the left side? I think it's, let me just check. Yeah. Let me write it down. Select. What is happening? For God's sake, let me just write it down yet again. Okay. On left side, the pressure on this part, at this part is equal to, here the pressure is equal to upper ka pressure, top pressure by A1 plus rho GH will be equal to mg by A2. So we have to calculate force on left side. The pressure, the area is 25 plus rho, the value of rho is 0.78 into g ko 10 le liya. We take it as 10 and the height is 8 will be equal to mg 6000 divided by A2, that will be equal to 800. On solving this, you'll get 31 Newton. So hopefully this is clear to you all, right? So try these type of questions. You just have to equate, you just have to apply Pascal law, or you just have to equate the pressure at any given point, right? So hopefully this is clear. We'll meet in the next class. Till then, keep studying. And sorry for the technical glitches happened today. We'll try to, keep it easy in the next class.